Okay, I'm going to go ahead and get started here, and hopefully you can see my screen okay. And if you have any questions as I go through this, please do feel free to use the chat window. I'm going to do my best to sort of periodically check that chat window because unfortunately our other host Rory Fox couldn't join this morning. So I'm gonna try and pull double duty and take questions here as I go through this. Um, and I won't dig in too deeply on any of these features except to sort of go through what's new in EDX as of this last year and touch on a little bit sort of what we're looking forward to in the next year, in the next couple quarters. But especially I want to focus in on a couple features and a couple new modules and options that folks might have missed that are worth talking about. So I'll go ahead and jump into this. And the first item, and this is an add-on module, an add-on feature set that some of our customers requested, specifically those that are already using Esri ArcMap or are, in the Esri ecosystem as a GIS tool for their enterprise. The new 3D viewer module will allow you to have a project in SignalPro and easily push that project back and forth into Esri and have an on-the-fly window to interact with your project. So I've got a SignalPro project here, and with my Esri 3D viewer subscription, I can click on this display perspective viewer option. Oh, is this not going to work as well now that I'm hosting on a screen share? There we go. Okay. I guess hosting on a screen share can slow me down. But so what I've got here, you'll notice that my various layers from the project are over here available on the left-hand side. And I've got a couple different project windows where I can, I can move these around independently of each other to find a site I need and zoom in on it or what have you. But this is within, Esri's nice, fast, clean 3D viewer tool. And, of course, if I've got studies or let's see here, my multi-point studies, if I've got study results that I want to plot on the map, I can do that. And I can zoom around to the, what might be problem areas and see kind of very intuitively why some of these CPEs might have marginal coverage. And I can also add equipment to the map. If I wanted to zoom way in and find a specific rooftop and add a CPE or add a base station, that's all doable with this 3D perspective viewer. So that's a neat sort of dynamic feature that, again, especially folks who are already sort of into the Esri ecosystem, really find it nice to be able to interact with their project in this way. So next up are the sustainability features, and I think these were just coming out at the beginning of 2024, but we've fleshed these out substantially. And I won't go into a full demonstration of this one, but essentially what this will let you do is set up power schemes for each of your base stations in terms of how many carriers are active, how much transmit power each one of those radios takes, what the amplifier efficiency is like, all of that stuff here. And then the overall power usage is analyzed and reported over here on the left. And that happens on the fly, too. I can make changes and see those changes update right away. And the analysis that we're using is based on the industry standard Earth power model that networks are starting to use to evaluate how much energy their base stations are consuming. And of course, there's potential for regulation of this in the future, and just from a cost standpoint, networks are trying to lower their power footprint where possible. So if you need to compare two different technologies, and the benefits that they would bring versus the additional power consumption, we've got the feature right there in the tool to do that. And it's a nice straightforward feature to use. Although to be honest, I had to go and look up what some of these values mean and where to find them in the equipment spec sheet. This had not been a part of my planning experience, and maybe it's not a part of yours either. But it's not that tough a hill to climb. You can figure this out and figure out which sites and technologies are more efficient. Next, we have a bunch of new and expanded items in the technology modules. So the network design modules for LTE and 5G, we have added to that NB-IoT and LTE-M, which are crucial smart cities and IoT technologies. And those would be in addition to our LoRa network module. So whatever IoT technology you might be using, we're set up with all the appropriate study types and additional features like PCI code planning and all of that stuff. My project here is a standard LTE project, a 900 megahertz private LTE project. And the nice thing is, if you're already familiar with that LTE module, any of the other 3GPP-based technologies are going to be set up and work in the exact same way. So I set up my technology profiles the same way. And I can do all my PCI planning and neighbor lists and all that stuff under any of those new modules. Jumping back here, the new Wi-Fi module is up to date for Wi-Fi 5, and Wi-Fi 6 is coming soon. And that's, of course, for either outdoor Wi-Fi or indoor Wi-Fi. You can do the planning for both, or at a campus level, you can do outdoor to indoor planning. Of course, like I just said, the LTE and 5G modules are having new features and items added to them nearly every month still, just to keep up with the feature set that's expected for sort of a carrier class tool, and also to add some additional design functionality, which I'll go into in a minute as well. Finally, Tirana equipment and other proprietary OFDM solutions, such as the Motorola Canopy, otherwise known as Cambium, any of those new large channel spacing, possibly very advanced MIMO configuration technologies like Tirana, are now all supported by the WiMAX wireless broadband module. So, the WiMAX is a bit of an older standard, but under that module, you can also do custom FDD or custom TDD OFDM configurations that allow as big a channel bandwidth as you need and allow some of the really awesome MIMO improvements that some of these new technologies offer. So we can support that if you're not under the 3GPP or the IEEE standards with your solution. The live coverage contour feature is a new feature that this came about as part of our work on automatic cell planning and a fast automatic cell optimizing feature. And the first step of automatic cell planning is, of course, first being able to select the sites from the potential candidates. And we wanted a faster way to do this. And in the process of developing that faster way, we decided it's fast enough to go ahead and just build that tool into the software, because build the feature into the software as a hands-on tool, because it's really handy and fast as a way of choosing locations. Let me clarify my map a little bit here. So what I've got, I'll hide my existing sites for the moment. What I've got is all of my little blue dots here are candidate tower locations, candidate site locations that I brought in through my towers and poles database here. And these could be utility poles or leased cell towers with different cost factors associated with them, whatever the case may be. But in the view menu, I've got my live coverage contour option, and this kind of snuck in there. Folks may not have noticed that appearing in their view menu. And what I can do with this tool here is to choose either the fastest model is going to be my Anderson 2D with no clutter, or I can choose to use the propagation model rules that I've set up in the main program. And then I can set the maximum allowable path loss and the frequency in question. This project, like I said, was a 900 megahertz private LTE. So I'll go ahead and enter my 900 megahertz. And for my maximum path loss, maybe I'll allow a little bit more than that. And then if I start my live contour here, you notice I've got this snap to towers and poles checked. And so it's only going to use those locations in my towers and poles database. But as I move my mouse around here, oh, you know what? Maybe I'll give myself a little bit more allowable path loss. Let's say 110. How about that? Just so I have a prettier picture to look at. There we go. So as I move around from one blue point to the other here, the contour line that you're seeing is just a fast distance to the first cell edge. You know, there may be some other spotted coverage around this sort of basic footprint when we go and run the full resolution model. But what this is doing is just looking out along each azimuth at a reduced study point spacing and coming up with an estimate for the coverage contour of that site. And so in this way, I can go through and very quickly evaluate which one of these candidate poles might best fill in this little valley here. I've got, you know, several close to each other. How do I know which one's going to work the best? Well, you know, this one out here on the edge. Maybe I decide that. And so I can click and leave that contour there and move on, maybe designing a little further. Maybe I pick this hilltop one as well. And then I can pick one over here. And when I decide that I've got the area covered well enough, if I want to, I can come back into this and convert those frozen contours to sites, and it'll go ahead and add those sites in. So I'll show my existing sites here again. And let's say I've just added those, I want to add those 3 contours to the coverage. Hey presto, those are added into my group, and I can rerun my finished studies based on that. So that's a really neat way to choose sites by hand, but do it using a very fast propagation modeling approach. The next item here is actually a whole category of items for new land mobile radio features. And I'll gloss over these because actually next month's webinar is going to drill into in detail these items that you see here. First of all, we've got our downlink and uplink log normal reliability studies to be able to account for signal fading and show the % reliability on both the talk out and the talk in side. And the talk in side can be difficult, or in other words, the uplink side can be difficult for reliability if you're using voting receivers or some of the new systems use what's sometimes called macro diversity voting or IP-based diversity voting, where any base station in the network can contribute some of the signal, and it's reconstructed from all of the base stations together, which is different from traditional voting. Well, long story short, we have both of those study options available in the software, so that whichever uplink case you're using, we can correctly account for the reliability. And the TSB88 reliability Monte Carlo analysis, Monte Carlo studies, the TSB88 document has an update to those methods, which we have rolled into the software, and we've actually given you both versions of that Monte Carlo, the original version and the newly updated one, to keep exactly in line with their recommendation. And the differences between those are pretty deep under the hood stuff. So we'll talk about those in next month's webinar if they're of interest. Here we've actually got a cloud-based application that we wanted to call this out because it was a first of its kind use of the EDX cloud-based platform, in which users needed to be able to really quickly generate estimates for the bill of materials just based on the exterior building polygon, using an address lookup and figuring out the square footage, and then quickly assessing sort of how many radios and what the bill of material might look like across a large area with a large number of buildings. And this was custom work that we put together, and we're able to run this very quickly on the cloud and make these estimations that potentially could have taken, you know, weeks or months to do that kind of analysis in a traditional tool. So that was a neat use case for our cloud-based platform, and we just want to encourage you, if you have a planning problem that seems too big, or that none of the planning tools out there really addresses in quite the right way, or is maybe a combination of a GIS problem and an RF planning problem, do feel free to reach out to us and schedule a customer success call. We can talk about what you might be able to do in SignalPro and what we might be able to offer in the cloud if there's something custom that needs to be done. Here's another fun and useful feature in the software, a change to the GUI itself, where the use case here is that if you're deploying fixed subscribers or CPEs out in the field, there are going to be some practical limits to the maximum or minimum antenna height that you're going to accept for those. And depending on the band that you're in, there might be some regulatory maximum heights. So in our CPE antenna limits option here, you can now define the minimum and maximum heights for CPEs, and when the actual CPE height that you plug in falls outside that range, the tool will default to the defined limits and push the CPE to the right height. This feature came about, it turns out it applies to more use cases than just this, but this feature came about for FWA analysis and the broadband data collection filings, where they had some rules about the antenna height minimum and maximums that could be assumed for the different filing requirements that they had. So we implemented this ultimately to make BDC filings easier, and it turns out to be useful just for sort of doing data cleanup as you bring in your CPEs. Mesh module enhancements. This is another one of those sort of too big to list all in one quick slide, but we've been doing a lot of ongoing work with our mesh module, including making the Mega Mesh GUI, the Mega Mesh design dialogue, a modeless dialogue, so that you can get out of that and save your SignalPro project as you're working in the MegaMesh tool without having to go in and out and take the time to reload that MegaMesh data. And so especially if you're working with larger projects, if you've got hundreds of thousands or even millions of meters in your project, this modeless GUI actually winds up saving quite a lot of time. Another neat one is the automatic repeater chain tool, where this is mostly for very rural deployments, either of AMI or distribution automation, long-range SCADA, that kind of thing. If the endpoint is too far out from the network to be reached by a single repeater from the mesh, our automatic repeater chain tool can either take your candidate locations or just pick locations freehand and create a chain of repeaters as efficiently as it can find to get out to whatever distant location. And again, this has been really, really useful for doing things like distribution automation in extremely rural, extremely rugged areas where that design could otherwise take a really long time. And finally, the mesh module supports multi-frequency meshes and adaptive modulation, where you can have different layers of the mesh operating at different frequencies with rules about which types of device can communicate at which frequency. And that mesh can also support adaptive modulation, where you can set rules about how it will choose its parents based on signal quality, and see the mesh diagram for how far out into the mesh you can extend your high-speed data rates versus just the lower speed data rates because of limitations in signal quality. So again, this is maybe for low data rate AMI. This feature set has not traditionally been all that useful, but as we get into smart cities and the sort of smart utilities applications where they're querying the meters more often, or if we're looking at broadband with some lightweight meshing or store and forward hopping, these features really help to support those more advanced mesh and store and forward types of use cases. So we're going to keep working on that mesh module and making sure it can support any of these new emerging technologies. But as of today, it's already really full featured. Again, if you have a mesh or a hopping, store and forward hopping type of network that you want to look at reliability or look at automatic site and repeater placement within that, do reach out to us and set up a customer success session. I love to talk about that. Okay, so finally here, a few items that we've got coming soon, and some proof of concept work that we've already done, again, in our cloud. First, the coming soon, and this is a SignalPro feature, automatic cell planning module. This is not just the automatic site selection that we have today, but a full cell planning module to work with antenna pointing azimuths and heights and transmit powers and all of that kind of thing to optimize the overall network configuration and get the best performance. And this ACP tool is being set up to support multiple different technologies. So whatever you're using, you should be able to use this ACP tool for it. And again, that'll be a SignalPro module. High altitude limitations have been taken out of the software already, so you can put a subscriber or a base station at a pretty ridiculous height. Well, at least ridiculous unless you're hanging it from like a high altitude balloon or a satellite or something like that. The satellite studies are the coming soon portion of this. SignalPro does not currently include a propagation model that's really designed for satellites, but that is in the works, and our altitude limits have already been taken out. So there's some interesting aviation use cases and high altitude balloon APs and that kind of fun thing that you can model in the software now. On the cloud-based platform side, one of the things we've done is create an API for connecting the OSS network management software directly to our cloud-based platform to update configurations and bring in live network data on the fly, and then use the planning tool to predict the outcome from potential network changes and all of that sort of thing. And so this is interesting mostly on the carrier side, but even some fixed network operators are really interested in being able to plug in that live OSS data and look at how well their predictions are matching what's happening in the field and tune things up and all that sort of thing. Finally, an interesting use case that we did also on the cloud-based platform, although this would potentially be a feature that could go into SignalPro in the future as well if there's demand for it, is the idea of bringing in crowdsourced cell network data. So there are a number of different providers that get data from cell phone users on signal quality, what carriers are available, all of that sort of thing, and make that data available internationally. And some of our users had the problem of needing to decide, for example, and this is in AMI, so in utility metering, they knew that most of the time they were not going to build their own RF network. They were going to turn to the cell carriers and put a cell card into the meters. The problem is, which cell carrier should they choose for a given neighborhood in order to get good performance? Relying on the cell carrier's coverage maps themselves may not be the most reliable approach. And so we did a proof of concept to show some of this crowdsourced data and allow the customer to query and decide for a given area which of these systems is the best system to support the fixed subscribers or the overall area in question. And so that's not really an RF design task, but it's sort of a task that's associated with putting together a complete network. If you're going to work with the carriers, you need to know what the carriers really have out there. And so that crowdsourced data was a really neat way of bringing that visibility into the software and seeing what's available where from the different major carriers. So I think, yeah, that's all I have for you today. I apologize, I went just a little bit over the half hour, but that's sort of the wrap up or just the highlights of the features that went in during 2024, and we've got more coming soon. If there's a pain point in your planning process or a problem that you need help to figure out, please do reach out to us either through support or through your sales manager, and we'd be happy to help you. Again, thanks for your time today, and we'll talk to you soon.